looking at our review. And here are the problems I'm going to look at first. And then we will go back and we might add to that if this wonderful first period blue team has any additional questions. So right now we're going to be looking at 8, 11, 16C, 24, 25, 26, and 66. So I'm going to go in that order. So if you don't have any questions on any of these, and you're good on all of those, you might just jump to the end or closer to the end and kind of see if I've added anything on towards the end of the class. All right, but this is the order I'm going through first. So number 8. And also, guys that aren't here, if just make sure you don't, anything that requires an actual graphing calculator, what number did we say they were?
29 and 30.
Number 29 and 30, we are not doing those. So anything that requires a graphing calculator, we do not need to do. Oh, I did remember what I was going to say. Next week, if you guys, you know how you're not going to be here Monday when they're testing, and I have a video for you. If you don't want to enter a whole bunch of new brain cells in, just take the test on Tuesday and then go watch the video at home. And that way you can kind of put off adding too much junk to your brain. And then just do the homework that night if you want, okay? Because Wednesday we're going to have basically a quick Google Meet and another video. So you're going to really sadly have back-to-back videos for me without interaction, but or a whole lot of interaction. But you're welcome to do that if you want. Just wait till after the test. And it's going to be that way as long as we're doing this A-B thing. You're probably going to be taking the second test, and you're going to have a video the day before, which is just more information to enter your brain. So if you want to hold off, just wait till after the test. All right, so number 8. Number 8 says write an equation which represents the relationship between x and y so that x comma y is equidistant from 2, -1. So they're giving you 2, -1 and 1, 7. Now this was actually a homework question. And I believe one of you asked me about it. And I sent back a quick video to you or something. But one of you asked me about it. It might not have been this class, but somebody in pre-cal asked me already about this, which is good. But it was a homework problem. Now, let me just draw a picture of this real quickly, just a rough sketch. I've got 2, -1. And I've got 1 up 7. So the question was, what is the relationship between x and y so that xy, what do they mean by xy? What do they mean by x comma y in parentheses? That's what everybody thinks. But what they mean is the points, right? It could be the midpoint. In fact, it does include the midpoint. But what about other points that are equidistant from these? Now, clearly, the midpoint, whatever that is, that's equidistant, right? Same distance. But what about this point? Is that the same distance? Or that point? So I want the collection of points. Now, how do I write a collection of points? In this case, a line. But an equation is how you represent the relationship between x and y. So basically, I want all of the points, and this is not maybe a great picture, but I want all the points that are equidistant from these 2 points. And yes, you're right, it does create a line. So, how do I find the equation of that line? I need a point. For any line, I need a point and a slope. So, the point I can find by doing midpoint. See how they bring it all in here at once. So, how do I find the midpoint? Add the x's and divide by 2, and then add the y's and divide by 2. So 3 over 2. So the midpoint is going to be 3/2, and then the midpoint of the x's, and then the mid of the y's is going to be 3. So there's your midpoint. That gives me that. Now what do I need? Good. So I'm going to have the relationship between this slope and that slope is they are negative reciprocals because they're perpendicular, right? So let's find the slope between these 2 points, which would be the slope of that line, and then do the negative reciprocal to get the slope of that line. So the slope between these two is what? Y minus y, which is 8, over x minus x, which is negative 1. So I get a negative 8 slope, which kind of looks right? Up 8, left 1. And then I want the perpendicular slope of that, which is positive 1/8. And by the way, you guys have your phone out probably or looking at the key. If I'm wrong at some point because of a careless error, please tell me, because we're putting this on film, you know? I would rather the people at home actually have this right. So just feel free to go, 2 plus 3 is not 6, Mr. Herring, whatever. So now that I have the midpoint that I want and the slope of the new line, all I got to do is throw it into my point slope formula. Y minus 3, 1/8, x minus 3 halves. And guys, I'm going to start saying this over and over. Please do not feel the need to simplify this. This is an equation of a line. That's what AP likes to see anyway. Now, if it's a multiple choice question, then yes, very well, they very well may clean it up and put it in point slope, slope intercept or standard. But not all the time. A lot of times it looks just like this. So if it doesn't tell you to put it in a certain form at the end, man, leave it. I can't tell you how many times people do this correctly, and then they distribute that in incorrectly, or maybe add the 3 incorrectly, and then their answer's wrong, and I got to dot them because their final answer is wrong. And AP's the same way. You'll lose that point for your answer when you circle a different answer. You got track with me? Everybody got this? All right, that's number 8. So here's the equation, the relationship of all the points that are equidistant from these two. It would be that line. All right, so that was 8. Number 11. All right, so here is this factoring problem. It says just to solve, but we know that when we have an equation like this, to solve it, it says equal 4, but since it says equal 4, I'm going to go ahead and subtract that 4 from the other side, so it'll be a minus 4 and then equal 0. And they're asking me to solve. Now, I have a question for you. What if the problem looked like this? If it looked like this, would you be having any troubles with this? No. So do this. Think of this as an x to the 1/3 squared. And then this is just an x to the 1/3. Does that make sense? And if you do that, then then you can kind of, if I was really doing it in a formal way, I would say something like this. Let A equal x to the 1/3 and make a temporary substitution. A squared minus 3a minus 4. And now it looks pretty. And now we can factor it. A minus 4 plus 1. A equals 4. A equals negative 1. Now, I got a question for you. If I was absent today, what would happen? No, what would happen for you in this class right here? No, like, visualize it. Is just nobody going to be here? They're going to send somebody in here, right? There'll be somebody who's a substitute for me. Now, if they stay here forever, they're not a substitute, right? They're a permanent replacement. That would be your new teacher. But a substitute's going to come in here, so legally you have somebody watching over you in case Merle gets crazy and turns into a wild man, right? They got to have some kind of level of authority to make sure everybody's safe, right? Legally, otherwise the school gets sued, right? And then the Reeves might sue the school and get a huge settlement and your mom can go home, right? And rest in peace. Okay, so somebody has to be here, but in the end, they have to leave and I have to come back. So in the whole idea of a substitution, it's temporary. I'm going to temporarily make the substitution to make it look pretty for me, but in the end, what do I have to do? I got to plug the x to the 1/3 back. Don't forget this. Everybody, not everybody, but a lot of people do all this right, and then they tell me the answer is -1 and 4. But you never made the substitution, right? It was a permanent replacement. You can't do that. So at this point, how do I solve for x to the 1/3? Yeah, it's already a cube root, so you're going to cube both sides, cube both sides. It gets rid of the cube root, and I get 64. And hopefully you guys can see that on the video, but you end up getting 64 and -1. And you could go back and plug them in there and make sure it works, but in the original problem, do you have domain issues on x to the 1/3 graphs? No, they go forever to the right. Unlike a square root that has a domain, x to the 1/3 goes forever that way and this way. So I don't know, if I've done the math right, if I get a pretty answer like that, you can have a lot of confidence you're correct. All right? Okay, moving on to 16C. 16C, are the following equations symmetric about the x, y origin or no symmetry at all? Okay, so great question. This is 16C. Y equals. Okay, so in your work somewhere, I talk about symmetry, okay? And there are 3 kinds of symmetry. 2 that we've talked a lot about, but there is actually x-axis symmetry. Okay, now I can tell you right now, if it looks like a function, which it does, all right, y equals, or f of x equals, and there's no crazy thing like a plus or minus in there, then it's not going to have x-axis symmetry. Okay? You know right now what a cosine curve looks like, right? Cosine curve, stretch, so it's a little higher, shifted up 2. Starts 2, a little higher. That passes the vertical line test, right? Well, is there any way you could have x-axis symmetry on something? To have x-axis symmetry, a cosine curve would have to look something like this. You know? Or maybe like this. And this graph is not going up and down, it's going left and right. So I'm not even going to do the x-axis symmetry check, but I'm going to tell you what it is. So here's how you check for x-axis. But again, if it can be written in function mode, you really don't have to do that check. Because if it's in function mode, there's no way it has x-axis, because x-axis symmetry won't pass the vertical line test to be a function to start with. But here's the check. The check for x-axis sim is change y to -y and simplify. If new equation equals old equation, then you have x-axis symmetry. So, just to give you a little vision of that, if I were to change the y to a -y, right? And then simplify, and I guess simplify, I'm trying to make it exactly the same as this. So if I went back through here and say multiply it through by a negative, does my old function look like the new function? No, then it does not have x-axis symmetry. We learned, but I kind of knew that already. Now what about y-axis symmetry? Now we learned that cosine functions, basic ones, do have y-axis symmetry, don't they? Because they kind of start a little high on the y-axis. And this thing did not have a shift left or right, right? So it's still there. So I know right now, based on what I know about graphing cosine, that, and we'll learn a little bit more about that when we go through it, but I know a little right now that this is going to have y-axis symmetry. But here's the y-axis symmetry check. And these are kind of easy to remember, I think, once you kind of see them all. So for y-axis symmetry, change the x to -x and simplify. If new equation equals old equation, then you have y-axis symmetry. So let's try that. Change the x to a -x. Now, didn't you learn last year, and I know, sad thing is I didn't give you quizzes on all your identities, because it's really hard to do that when you have an open notes test and you're staring at the identities. You know, trick question, what's cosine of -x? Cosine of x. So you didn't have to memorize them, so they're probably not burned into your brain like they are with previous classes. Hopefully this year I will get them burned in, but still, if I only see you twice a week, it's going to be, I normally give a quiz every single day when I do trig. Like literally every single day for a week, and people feel really good about their identities at the end. I see you twice a week. And what you know on it is going to be different than what the next class knows. So what we did learn, though, that cosine of negative x equals cosine of x. So what could I do with that cosine of negative x? Change it to a cosine of x, and now they match. This has y-axis symmetry. Last check, origin symmetry. Okay, so for origin symmetry, For origin symmetry, change the x to negative x and change your y to negative y and then simplify. If the new equals the old, then you have origin. At the end, I'm going to tell you one other way you can do y-axis and origin. So let's see. If I change the x to a negative x, and I change the y to a negative y, and then I try to simplify. Well, the first thing I can do to simplify is go, well, because of this rule, that becomes a positive. So that part's the same. But to get y to match y, I would have to multiply through by a negative. And I end up with that, don't I? Does the new equal the old? So it doesn't have origin. All right, so those are your tried and true checks for x, y, and origin. Now, do you remember another way you can do y-axis? Y-axis are even functions. 2 is like 2x to the 0. That's even. You learned that cosine and secant are even. An even plus an even is a even. If it's an even function, it's always going to have what kind of symmetry? Y-axis. Are y'all seeing that? How about this? What if I gave you this? What do you know about this function right here? Odd because it has an odd power. What do you know about sine? That doesn't have a shift, right? What do you know about the sine curve? It's always, the only ones that are even are what? The only trig functions that are even are cosine and secant. So everything else is odd. Sine is odd. What's an odd times an odd? Even, because it's like a negative times a negative. That's an even function. And if it's an even function, it has y-axis symmetry. So there's other ways to do it. And there's obviously the definition of even and odd. And again, if it's even, it has y-axis. If it's odd, it has origin. But you can always do this stuff. All right, that's 8. Now that's 16C. 24, 25. So 24 is absolute value. I'm giving a test to my Algebra 2 classes right now. Today and yesterday on this topic. So here is 24. 4 plus 2 times absolute value of 3x minus 2 less than or equal to 8. So, do you remember the hint I gave you on solving these? Anyone? Isolate. Why?
Because you can split it into the positive and negative.
Right, but why don't I just go ahead and multiply 2 in there? Or why don't I just add a 2 to the outside? There actually are some rules that allow you some freedoms. But to me, like, I know that we can't access all of our brain. You know, they say if we could access all of our brain, we could like move objects with our brain and stuff. I don't know if I buy into that, but whatever. They made a couple movies about that. There was one with like, what's her name? Who plays the superhero, Scarlett? What, is it Johansson? No. Who's the girl that plays in the Avengers?
Black Widow.
Black Widow. Who plays her?
Scarlett Johansson.
Yeah. Okay, she played in a movie where she accessed her brain and all of a sudden she was taking over computer systems. Y'all not see that?
Oh, yeah.
It's kind of dorky, but have you seen it?
I've seen like a commercial.
Commercial?
Yeah, I remember.
Yeah, it's not super awesome, but my point is, I only have access to a limited part, but that part still feels like it fills up rapidly. So I'm not going to memorize extra rules I don't need to. Like there are rules that say, you know what, you can't actually factor out a positive number out of this. So I can factor a 3 out and have x minus 2/3 and put a 6 there. But how does that help me? I can multiply a positive into that. I'm allowed to do certain things, but I don't mess with it. I just isolate it, break it up like you guys were saying based on my rules, and then I can save some brain cells for like figuring out what shoes to wear or something. I don't know what, whatever. So I'm going to subtract 4. Hopefully I don't need a whole lot of brain cells for that. And then I can divide by 2. And what's the rule? What's the rule on inequalities? When you ever divide by a negative, you change the direction of the inequality. Well, that didn't happen here, so I'm okay. And then at this point, I have to decide, is this, and when I split it up, is it an and or an or problem? And our trick was, if the absolute value is here, I read it from the absolute value. This absolute value is less than 2. And if it's a less than, then that means this is an and problem. But I showed you a little trick on and problems. Because remember, and problems end up being combined inequalities, the 3-part inequalities. So a little trick is this. And you can do it either way. This is the non-trick. 3x minus 2, so leave that the same. Or negate that, negative 3x plus 2, and put an and there. But you know what? I don't love this way because now I have to solve 2 problems and then combine them back together with the word and. And you know what? I remember grading your test. A lot of you guys, the and the or thing got you confused. You're like, wait a minute. And if you've forgotten that, and means what? The intersection or the overlap of the 2 things. If I told you to go stand on Lakeshore Drive, you got a lot of options, don't you? Right? Miles of options. If I said stand on Green Springs, miles of options. If I said stand on Lakeshore and Green Springs, where are you headed? Right to the intersection. Right? And means intersection. Now, or means what? If I said stand on Green Springs or Lakeshore, I'm probably not going to find you. Right? Unless you just walk right out to the street there. That's probably where I'd look. After that, I'd probably like, I don't know, I'm not going to find it. Or means union. Put it all together. Anywhere on there. So this is an and, but look how much easier it is. And some of you, I think I saw somebody this morning who already did this. They said, just write down what you normally would have put first, which is just the not change anything version, and then do this little trick. Take this and put the exact same symbol there, and then take 2 and put it there, but change the sign. And that's a little trick, because remember, and is a combined inequality. So you could write and, or you can write a combined inequality. I like this, especially when it's just a little simple number. So 2, negative 2, and all I have to do now is add 2 to all 3 sides, and divide by 3. And look, it's already combined together, and I don't even have to write the word and down because it's built into that. So that would be the solution to this, and it didn't ask you to graph it, so I'm going to stop right there. All right? All right. Now, 25. You'll notice that 25 got the what? The star. The infamous star, which means I'm trying to really work you on this. Now let me ask you a question. If it only had one absolute value, what would you do? Sometimes it's going to be the positive or unchanged version. Sometimes it's going to be the negative version. But you still have that other one. So the other one could also be sometimes it's unchanged, sometimes it's negated. Well, that means they could both be positive, both be negative, one be positive and one be negative, or one be negative and one be positive. That's 4 different options, right? You want to know a nice, neat little trick to this? Write down all the options and mark those values when you solve on a number line, and then just check points. It'll make it so much easier. Check it out. X minus 7, x plus 2. Okay, so watch what I'm going to do. I'm just going to write 4 equations out. So I'm going to write both of them unchanged. All right? Now I'm going to write both of them negated. Tell you what, let me make more room. Both of them unchanged. Right? That's kind of like, don't change it, don't change it. Both of them negated. This one negates, so this is both negated. This one negated, this one not changed. That'd be like negative positive. And then finally, this one positive, this one negative. And guys, I hope you can see this. And I'm not even going to worry about how these things are joined together because I'm going to go back at the end and guess and see which ones actually make sense. So let's solve. Right here, when I subtract x's, you cancel. What? What does that mean? Is that ever true? Ignore that. What about this? 7 greater than or equal to a negative 2? Is that ever true? That's always true. So it doesn't matter what you plug in for x there, you're going to end up with this relationship. All right? If I plug a 5, a negative 5 and a negative 5, 4 and a 4, they're always going to cancel. That's always true. All right, what about this one? Here's where you start having to, if I add x and subtract 2, I get 5 less than or equal to x. Okay, that's something I can put on the lumber line. It might make some sense. Right? Oh, sorry, 2x. Sorry. Good, that's what I'm talking about. Correct me. Don't let it go down in infamy as just careless terribleness. All right, so values smaller than or equal to 2.5. And then right here, if I add an x, I get x bigger than or equal to 5/2. Now, ignore the inequalities at this point. Okay, just mark these values on a number line. Nothing, everything, and then here I got this 5/2, and that's the only number that ended up showing up, wasn't it? So if that's the only number that ends up showing up, I'm just going to check over here and check over here. I know that it's equal to 5/2. Let me just double check and make sure that that makes sense. If I plug a 5/2 in, what's 2.5 minus 7? Negative 4.5, which becomes positive 4.5. What's 2.5 plus 2? Positive 4.5. That is equal, so I'm going to keep it. Let me pick something smaller than that, like 2. If I plug a 2 in here, I get negative 5 absolute value. If I plug a 2 in here, I get 4 absolute value. That's true. So I'm going to shade this side. Are you with me? Let me plug a 3 in here. If I plug a 3 in here, I get negative 4 absolute value. Here I get a 5. Is that true? No. So my final answer is everything smaller than or equal to 5/2. So if I ever get something really nasty with 2 absolute values, which shows up at a math tournament all the time, not that that may impact us this year, but if it happens, just do this. Rewrite it as positive, positive, negative, negative, positive, negative, negative, positive, solve all 4, just mark, ignore the inequalities. Who cares about what they say here? Just mark them on a number line, because this definitely said everything bigger than 5/2 did not end up being true, did it? So don't worry about that. Just mark the values, whatever you get on here. You might have 2, you might have none, you might have 4, and then just check in between all of them, and that'll be your solution. It's not quick, but it's a much easier way than trying to do it a different way. Absolutely not. No, that's great. If she asked, could I write negative infinity all the way up to and including 5/2 in interval notation? Fantastic. That's what they love to see in a math tournament, because some teachers don't teach that way, and they can get kids to miss stuff, but we do a pretty good job of that. I used to think it was like this awesome when everybody wanted that, and then you get to AP Cal and you see they write it like this, as much or more than they write it like that, so you'll be in great shape, you'll be comfortable with both. That's 25. Wow, maybe running out of time. 26. Well, we won't be able to go longer in this class. Only when I do like recorded videos. All right, it says, what is that equal to? But wait, I only want to know what it's equal to when x is less than 1. Okay, so here's the thing. Absolute value, sometimes it's an unchanged or the positive version of that, and sometimes it's a negative version. But wait, I want to know when is it what? So let's start thinking for a second. What are values that are smaller than 1? What, 0.9, 0, a half, -5, -1,000,000. Anything smaller than that, right? Let's take some samples. What would happen if I put like 0.9 in there? I get what? 1.8 minus 3, that's definitely a negative. What about a 0 in there? -3, definitely negative. In fact, this is going to be a negative number inside there is for anything smaller than what? 3/2. Well, that's smaller than 1. That's definitely smaller than 3/2. So any of these numbers that are smaller than 1 that I plug in here, all of this ends up being an absolute value of a negative. And what do you do with absolute value of negatives? You make them positive. So doesn't it sound to you like this definition of absolute value is going to need to be what? Negated to make it, the absolute value, go away. Because every value smaller than 1, when you plug it in there, makes that a negative number, and you, to make the absolute value work, would have to negate it. Drop down the negative, drop down to 5, and I end up with 5 plus 2x minus 3. So this is equal to 2x plus 2, as long as the values are less than 1. Now what if I said for values bigger than 2? Values bigger than 2, what happens? They all end up being positive. And if they all end up being positive, do I have to negate anything? No. So just throw away the absolute value, distribute the negative in, and you would end up with 2x plus 8. But for basically what they're saying is, you don't have to plug it in here anymore. For any value less than 1, you can just plug it in there. It's a lot less thinking. But for any value bigger than 3/2, or like maybe bigger than 2, then you would plug it in the other version that you'd end up with. All right, and then finally 66. And if you come up with any numbers right now, you can give them to me. And I will just do them in the next video, and then just put 2 videos on there. Hopefully, if I think about it. Okay, you remember we just talked about in the video from yesterday, joint and inverse and all that stuff, didn't we? If you watched the video from yesterday, I hope you guys are keeping up. I can tell that some of my Algebra 2 kids aren't watching any videos because they just ask me the absolute worst questions. Some of the questions, I'm like, dude, really? Like, how are we supposed to know about so-and-so? The video we've been watching the last 2 days. I mean, whatever. Hopefully you're watching. But here we go. It says x is inversely related to the square root of y. What does inversely mean? X, this was number 66. X inversely means times. X inversely related to square root of y. But also x is what? Jointly related. Jointly means to divide it by a product. Because if x is jointly related, there are 2 things on the bottom. And it says it's jointly related to w and the cube of z. Z cubed. Not the cube root. Inversely, jointly. And you got to make those times. So if I think about this as a constant of like a little k, that's always going to equal the same thing, then that means x1, y1, w1, z1 would be equal to x2, y2, w2, z cubed. So if they have little 1s on them, little 2s on them, that would be the relationship. And it's always, this fraction is going to be equal to that fraction. But then they gave you a bunch of numbers. They said, if x is 9, y is 16, w is 6, and z is 2, then find x when y is 625, w is 10, and z is 5. You think you can do this? So 9 times 4, I'm not even going to simplify any of these and make a 36 there because I'm going to want to cancel in a second. 6 times 8, x times what? 25? And you know that because that's a 5 to the 4th, and the square root of 5 to the 4th is 5 squared. Good thing we learned those powers, and hopefully didn't forget all of them. And then 10 times 125. Now you can start canceling right now if you want, or you can just cross multiply, or you can do the slide rule. Do you remember the slide rule? The slide rule is essentially basically multiply both sides and then divide both sides by a 25. Or basically slide the 25 down and the 10 and the 25 up. And now all I have is an x. I can just cancel to my heart's content. 2 into that, and 3 into that, and I end up with 45 over 2.
I think 45 goes into 125 5 times here.
You are correct. Got it. Thank you. That is not 75. So that and that would give me a 5. 9, 4, 6, 8. Bring up the 10 and the 125. Bring down the 25. Nothing else? 25, is that right? 3 and the 9, sorry. Have a little problem. 75 halves? 75 halves. Thank you. All right. All right, guys at home, hopefully that's helpful. If you have any other questions, that's pretty bad on you since you won't watch this video until probably too late. But you guys, I may try to, if you have something, you can email me before 7th period. I might be able to work up another video and post both. And again, I will try to do them numerically in order, and I'll try to post the numbers at the top. So if you have that question, just look at the video and you might see your number being answered. Anyway, all right? Good times.